Very good morning to all of you. Hope I am audible.
Good morning, sir.
Yes, sir. Good morning, sir.
So this is our second class in this semester for the course Dynamics of Machinery, ME 1402. Okay, so this is already 5 past 9:30. And this is the last class I am allowing students after 5 minutes. So from the next class, you must join at 9:30. Before 9:30, you must join. Okay, after 9:30, I'll not be allowing anybody in the class. Okay. And so only 2-3 minutes I can allow you in the class, but not after that. And many of you have not still joined the team. I don't know why.
Sir, many are having difficulty in joining.
What kind of difficulty? First year students are doing. You are having
Uh,
difficulty.
They
And
have
you are
signing
having
problem.
difficulty, you are saying me at this point of time. Why? Why is it so? Let me know. Not go into that. I'm going to start the class. If you have any technical issue with the class, you must tell me after the class or okay. I mean, so let me share the screen. Is the screen visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Just give me 1 minute. Okay, let's start. Yes. Last time I'm entering all. This is our lecture number 2, and today is 11. So the first part of the course, as we have discussed the syllabus in our last class, the first part of the course will have these part that is called uh, number synthesis. Second is dimensional synthesis. Dimensional synthesis. Third, we will go for kinematic analysis. Fourth is dynamic analysis. Where we also will talk about flywheel. Uh, these all are for planar mechanisms. Okay, then the sixth topic we will go for is gyroscope. The seventh topic will go for, I believe, balancing. Eighth is after gyroscope balancing, we'll go for cam. Okay, and the ninth part is also you said you want to have some idea about governor. Very small thing, very small introduction to vibration because you have a separate course on vibration. These are most of mostly these are the topics I'm going to cover in this course. Okay. Uh, so today we start with the first topic that is called number synthesis. Okay. So we are starting today this topic, number synthesis. Number synthesis. All right. So let me record this class. Only for today I'm allowing students, not from tomorrow. Before I go into this topic, number synthesis, let us recap some of the definitions which you have already studied. I mean, so tell me what is called a mechanism? What is called a mechanism? A system or a combination of rigid and or restraining bodies. Restraining bodies. So shaped and connected that they move upon each other, so shaped and connected that they move upon each other, with definite relative motion. We have also studied another definition, which is the a kinematic chain, closed kinematic chain with one link fixed is also called mechanism. Okay. Now, what is the definition of a machine? Can somebody tell me? Can somebody tell the class what is the definition of a machine? What is the definition of a machine?
Sir, machine is a combination of mechanism.
Combination of mechanism.
Give a desired output.
Eh? Bolo?
Convert energy in from a particular task.
Yes, it actually transmit forces and When we say forces, forces also include moments. From the source to the restriction or resistance, which is also called load, to be overcome. Okay. What is called a kinematic pair? Please, somebody. What is called a kinematic pair?
Sir, connection between two links.
Yep. Joins in a mechanism. Joints in a mechanism are called kinematic pairs. Now, very important concept we're going to discuss is what is called degree of freedom of a kinematic pair. Bolo? Degree of freedom.
The way in which it
The
can
number
show
of independent
translation to
variables
physical
required
motion.
to
The number of different paths the links can move.
Minimum number of variables that need to be specified to fix the configuration.
The number of translation or rotational motion it can show in space.
Okay. So I'm giving you similar definition. I'm giving you here. Degree of freedom of a kinematic pair. We are asking for a kinematic pair. So this is the number of minimum independent coordinates required to completely specify the relative movement. Okay, we will come to some examples and discuss this. Next is what is called mobility. What do you mean by mobility? What do you mean by mobility?
The ability to move.
So this is the number of degree of freedom. So this generally we write DOF, degree of freedom of number of degree of freedom of a mechanism. We'll refer to that as mobility. Okay. Let us consider a 4-bar mechanism. 4R mechanism. What do you mean by this 4R mechanism?
So 4 revolute pair.
Revolute pair.
Pairs. R stands for revolute pairs. And if I say 4P mechanism, P for
Prismatic pair.
Prismatic pair.
Prismatic pair. Okay. So 4R mechanism means you have 4 revolute pairs. One of the link is fixed. Suppose this is the mechanism. Okay, we can give name 1, 2, 3, 4. 4 links are there. This joint is R1, R2, R3, R4. Okay, in this mechanism, suppose the length of this link, okay, this is say this distance is rho. Okay, now if we have a mechanism where we say that this rho tending to infinity, what will happen to the motion? First, let us understand what kind of motion this R3, this point is having. This point, this is a rotary motion at this point, right? Rotation about R4. Yeah, this point's motion like this. But suppose I take this radius or link length is generally what? Generally, we do not show this link 1. What is grounded is link 1. Okay, but suppose we have done that this rho is infinity. What does it mean? Let us draw other links, then it will be clearer. Other links are this point was R1. Here we have R2, and this goes to up to this distance. This point was R3. Okay, this link is 3, this is 2, fixed one is 1. But we are saying that this is at a distance which is infinity. Okay, this rho is infinity. So now, can you tell me what is the motion of this point R3?
Sliding pair.
This is on the straight line. Okay? This is on the straight line. So that means now this R3 is become a prismatic pair, right? For this case, yes or no? Hello?
Yes, sir.
Yes.
Yes, sir.
R3 is now a prismatic pair. So for all prismatic pairs, we can say that prismatic pair, a prismatic pair is a limit to revolute to a revolute pair. Is it not? You see any prismatic pair. Prismatic pair means there is the motion is translational motion. That translational motion, any translational motion can be presented as a rotational motion, but the rotational this axis of means the radius of this rotation is infinity. That means we can always say that represent any prismatic pair as revolute pair. So in our rest of the discussions in the number synthesis, what we will do, we will only consider revolute pairs and do the calculations. When you do the calculation, suppose there is a prismatic pair, but you are considering it as a revolute pair. And in the calculations, you are getting some results. Those results will give you correct result because the prismatic pair is a limit to a revolute pair. Okay. So now let us discuss this. Suppose we have a binary pair. What do you mean by binary pair? What do you mean by binary pair? Binary.
Set join.
What do you mean by binary pair?
Consists of two links.
Yes, pair is a kinematic pair, and this kinematic pair, we have two links connected at this joint. Okay. Question is, what is the degree of freedom of this pair? What is the degree of freedom of this pair?
1.
One rotational.
Okay,
One.
how this is one? Physically, you have some imagination, and you are now saying that this is one. How it is one? Somebody please explain.
Only rotation of 2
Sir,
is
only
possible.
rotational.
So let us first start
It
from the
can't.
beginning. First of all,
So it can't
first,
translate in any direction.
there is one hidden assumption, that is, these are all planar mechanisms. These are all planar mechanisms. Whatever we are discussing here are planar mechanisms. What it is called planar mechanism? Something. Suppose there is a rigid body. What is the definition of a rigid body? What is the definition of a
The
rigid
distance,
body?
No relative motion
distance between any 2 point is same
Huh?
throughout the motion. The distance between any 2 point of the rigid body is same.
Yes.
Remains
Distance
constant.
never change. Okay, that is a rigid body. Now any rigid body which is, or a combination of rigid bodies which are moving in space such that any point, if you consider any point which is moving, and that point's motion is or any other point you consider on the mechanism, those points motion are on the parallel planes. Okay, then that is called a planar mechanism. Okay, it does not mean the all the points on link 1 and link 2 hinge, all the points have to be on a particular plane. The points can be on a parallel plane also. Okay, the motion is on the parallel plane. Okay, so otherwise what happened in a plane? You have what is the thickness? Then you will not consider the thickness of any link or the pair. So planar mechanism means all the points are moving on a plane or parallel to that plane. Okay, then that is called a planar mechanism. Now you consider any rigid body or moving on a plane. So any rigid body moving on a plane. So what is the degree of freedom of a rigid body moving on a plane? What is the degree of freedom?
3.
3.
What are those 3 degrees of freedom?
Translation
Two
in x and y
translation,
direction
one
and
rotation.
rotation about z.
2 translation and 1 rotation, right? These are the degrees of freedom of any rigid body. Now, if you make it fixed somewhere, then what is the degree of freedom? All the degrees of freedom are arrested. Okay, the degree of freedom in this case is 0, right? On the other hand, suppose I take a link and hinge it to some point, that point is fixed. Hinge it to some point and that point is fixed. Or we can draw it this way. This is a hinge and that hinge point is fixed with the ground. Okay, now what is the degree of freedom of this link? What is the big degree of freedom of this link?
1.
1.
1.
One.
Why it is 1? Why it is 1? Because the two translational motion, they are restricted by this hinge. Okay, that is why only degree of freedom which is left is this. Now degree of freedom of this binary pair is equals to 1. Can we, let's go to the next example. Suppose we have a ternary pair. Ternary pair. I keep this one fixed. 1, 2, 3. So now for this case, what is the degree of freedom?
2.
2.
Because see, actually how many degrees of freedom for this case? If they are no hinge and no, if I do not fix any of this link, how many degrees of freedom? 3 into
4.
3,
9.
9, right?
Also
9.
9.
Okay, now 9 degrees of freedom होना चाहिए था, because there are 3 links and each link has 3 degree of freedom. 9 degree of freedom होना चाहिए था, but then we have one of the link we keep it fixed. Okay, so how many degrees of freedom left? 3 minus 1 into 3, that is, now we have 6 degrees of freedom. But then there is a hinge, and this hinge is restricting for each link. It has restricted 2 degrees of freedom, right? Any link, you consider this link, for this joint, how many degrees of freedom restricted? 2, right? For this link, how many degrees of freedom restricted? For this joint, 2, right? So actually we can write it 2 into what? This was 6, and actually there are, can we write like this thing? Let's move forward and then we'll understand this more clearly. Now we have a quater. Quaternary pair. So now what is the degree of freedom of this system? Of this pair, what is the degree of freedom?
3.
3.
This is 3.
3.
If I go for similar formulation, 3 degree of freedom for each link, one of the link is fixed. Okay. Now 2 into what?
3.
3.
3.
3. So similar formulation if we want to have for the first example, what we will have? This is 3 into
1.
1.
2.
2 minus
Yes, you are right. 2 minus 1 and then minus
2
1.
into 1.
So this is 2 into 1. Now you see one thing, when we have a binary joint, we multiply here with 1. When we have a ternary joint, we multiply here with 2. When you have a quaternary joint, we multiply here with 3. Right? This way, if we construct a mathematical induction that suppose we have a nth order, we have a nth order joint. Okay. Or let us call it ith order. Ith order kinematic pair. Ith order kinematic pair. That means we have I number of links. Ith order means we want to say I number of links connected at a joint. Okay, so suppose this is 1 and then you have 2, then you have 3, then you have some numbers up to I. So I number of links are connected. You can take any number in place of I. Then we have to write down what is the degree of freedom of this system. Okay. So what is the degree of freedom in this case?
3 into
I
I
minus
3
minus
into I minus
1
1.
into I minus 1 minus
2 into I
minus
minus
2i.
1.
3 into I number of links are there.
So
Minus 1 minus 2 into
minus 2 into I minus
I
1.
minus
I
1.
minus.
I minus 1.
I minus 1.
This is correct?
Yes, sir.
Yes.
Okay. So we have understood this one. Now let me go to number of, now this time we will only consider binary links, and then let's see what happened to the degree of freedom. Degree of freedom of a kinematic chain. Degree of freedom of a kinematic pair. 1, 2, 3. These examples here we have discussed the degree of freedom of a kinematic pair. We have considered here the binary, ternary, quaternary, and ith order joint. Now we will go for degree of freedom of a kinematic chain. Degree of freedom of a kinematic chain. So first example, let us take an example that we have links like this. 1, 2, 3. Okay. Among these, one of the link we have to make fix. Okay. We are fixing one of the link because if you want to have relative motion, then one of the, with respect to some link, you have to get the relative motion, right? And so that link you need to fix. With respect to that, what is the relative motion? Okay, number of coordinates required to specify, completely specify the motion of the kinematic chain. That gives us the degree of freedom of that kinematic chain. So in this case, suppose we have these 3 links are there. Now tell me what is the degree of freedom of this system. What is the degree of freedom of this system?
4.
Huh?
4.
4.
ठीक से बोलो. What is the degree of freedom?
2.
Yeah. So how it is 2? Because first link 1 is fixed. Okay. Now, what is the relative motion of link 2 with respect to 1? Only 1 degree of freedom, right? Because only this angle, if you know, let's say theta 1, if you know only this angle, you completely know any point you take on the link 2, because the length of link 2 is known to us. Obviously, it is known to us. Then any point on link 2, even this hinge point between 2 and 3, its position, if you know theta 1, you definitely you know what is the position of that point at any point of time. So this is 1 degree of freedom. Now, once you know the position of link 2, you need another coordinate theta 2 to completely define the position of any point on link 3. Okay. So from this argument, what is the degree of freedom for this case? Degree of freedom is 2, right? Because for this system, how many coordinates you need to completely define the position of this mechanism, configuration of this mechanism? Only 2 coordinates required. So that is why we are saying that the degree of freedom of this system is 2. Is it clear to you? Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Same
Yes,
thing
sir.
you can do.
Yes, sir.
You can somebody's mic is on. You can please on ये. All right, that is a prayer. Okay, so now we take another example. Suppose we have now 4 links. Okay, and now you fix one of the link. In this case, we have fixed link 1. You can fix link 2 also. Then also you will get this degree of freedom is equals to 2. Let us for this case, let us fix this link. Okay, 1, 2, 3, 4. Let us fix this link. Now, what is the degree of freedom of this mechanism?
3.
Not mechanism,
Three.
but this kinematic chain. Degree of freedom is? So this is
Three.
theta 1 maybe, this is theta 2, and this angle, if you know, theta 3. Then we need 3 coordinates, 3 independent coordinates, which are really minimum. Now let us explore what is the meaning of that minimum number of independent coordinates. You can say that theta 2 is equals to phi 1, phi 2 plus phi 1. ऐसे भी तुम बोल सकते, you can say that. Then somebody can claim that okay, we have 1, 2, 3, 4 coordinates, then degree of freedom will be 4. That is why that restriction is there, that they have to be independent. Now this theta 1 and theta 2 has a relation. Sorry, phi 1 and phi 2 has a relation that is equals to theta 2. So we have a, once you have a relation between coordinates, then that coordinate is no more independent coordinate. So that is why that definition calls minimum number of independent coordinates. So we have here 3 coordinates and the degree of freedom is 3. Okay. Now let us take another example. This is 1 link, 2 link, 3 link, 4 link. Okay. Now in this case, we are using suppose 1, 2, 3, and 4. Okay. Again, you can make one of the link is fixed. Let's say I am making this link 2 is fixed. So what is the degree of freedom for this case?
4.
3.
3.
1. This is theta 1. This is theta 2. This is theta 3. You can have another angle theta 4. Then you see that if you take this, suppose you have taken these 4 coordinates, theta 1, theta 2, theta 3, and theta 4. But you can see that there is a relation, that is theta 2 plus theta 3 plus theta 4. This is equals to what?
360.
This is equals to 2 pi, right? That means you have 4 coordinates, 4 coordinates, but you have another relation. This relation, when you have a relation like this, algebraic relation like this, that means all these coordinates are no more independent, they are dependent. So if you choose this, suppose for a particular system, if you have chosen these coordinates, you will see in actual problems we do not always choose the number of coordinates is equals to degree of freedom. Sometimes for ease of calculation, what we do, ease of calculation and analysis, we take more number of coordinates compared to the degree of freedom. in that case, we also will have this kind of relations, okay, the algebraic relations. So here you have a number of coordinates is 4 and number of relation is 1. So you have to subtract that from the coordinates and that gives you the degree of freedom, which is in this case 3. Is it clear to you?
Yes, sir.
Yes,
Yes,
Okay.
sir.
Actually, if you don't
Yes, sir.
don't use this coordinate R4, then also you can completely specify the configuration of this mechanism. Then the degree of freedom of this system is actually equals to 3. But to just to demonstrate you that for your case you may require more than degree of freedom, the coordinates more than the number of degree of freedom, then these equations are called constant equations. Number of coordinates minus constant equation gives you the degree of freedom. I hope you will not forget this. Okay, and let's see,
Sir,
we
can you
have
please repeat?
some huh?
Can you please repeat the last theory?
Yes, I will repeat. Let me check my last example. So what I am trying to say is you have already studied, many of you said it correctly, the definition of degree of freedom of a system, of a mechanism, of a kinematic pair. The main thing is what? The number of minimum independent coordinates required to completely specify relative movement. For this case, relative movement. But for actual definition of degree of freedom of a system is number of minimum independent coordinates required to completely specify configuration of a system. That means only this many coordinates are enough to completely specify the system's position or configuration at any point of time. But then for real analysis, when you go for analysis of a mechanism or a huge system, then you consider number of coordinates. You need to consider number of coordinates more than the degree of freedom. For the ease of your analysis, you can consider that. Then one can say, if somebody does not go by this definition, one can say that you have this many coordinate systems, means coordinates. So the degree of freedom would be like that. It is not true. Then you have to check whether all those coordinates are independent or not. You have any constant equation is there or not. If there is a constant equation, so number of coordinates you have chosen minus number of constant equation gives you the degree of freedom of the system. Is it clear to you? For this case, you can see that. This is example. From your physical understanding, you can say that, okay, why should we take theta 4? But for a complicated situation, you don't know actually. This picture is not clear there. There you have taken this theta 4. But also you will have this relation theta 2, theta 3, theta 4 equals to 2 pi, which is a constant equation, which is a relation between this theta 2, theta 3, theta 4. Okay, that constant number of constant equation must be deducted from the number of coordinates you have taken for your analysis. Okay, that number of coordinates here, if you take 4, this is 4 minus 1, that is the number of constant equation. So number of coordinates, number of constant equation, if you subtract, that gives you the degree of freedom of the system. Okay, all right.
Yes, sir.
Okay, let us take another example. Let us make the picture little more complicated. We have, this is one link, this is another link. Suppose you have this link, and here I join 3 more links, and you have another link where you join 2 more links. Okay, so now if I give the number 1, 2, 3, maybe 4, or you can number this way 4, 5, 6, 7, 8, 9 number of links are there. And let's keep this link 1 fix. You can keep this link line fix, no issue, or you can keep any other link fix to get the degree of freedom of this kinematic chain. Suppose I am keeping this link 6 fix. Okay, so now can you tell me what is the degree of freedom of this mechanism?
8.
8. So let us any other guess? Anyone else want to guess?
So, sir, 8 only.
Okay,
Sir, 8
so
only, sir.
let's count. Let's count it. This is, let's say, theta 1, this is theta 2, and then once you get this is theta 1, then you can have this is theta 3, theta 4, theta 5, and you can have a relation with this theta 6, theta 7, and so now another thing you must observe from this figure that I have taken thetas with respect to some coordinate. With respect to this, I have taken this. With respect to this, so this is a open kinematic chain which is relevant to today's very hot topic, that is robotics. In robotics, this subject is also introduction to robotics. In robotics, you have to analyze what the kinematic analysis. In the kinematic analysis, you need to know the position or configuration of these links at a particular time. Then for that analysis, you have to assign this kind of coordinates to each link. Now assigning these coordinates to each link sometimes have some rule. They follow some rule. Rule means, suppose I have not used any rule here. I have arbitrarily given a relation between links. So as I have done here, 6 with 5 and 5 with 3, and then 7 with 4, this way. But sometimes the rule of specifying these coordinates means which link should be related to another link, that will be specified in robotics. But if you understand this, you can understand that process also. So in this case, as we got the degree of freedom of this mechanism is, or sorry, not mechanism, this kinematic chain is 8. All right, now let's go back and try to get some formula from it. Okay, as we did for these cases, the binary, ternary, quaternary joins, what is the degree of freedom that we have found? But now for a kinematic chain, we will formulate like the same. So this case, for the first example here, we have how many links are there?
3.
3.
3 links, one
3,
of the link
4.
is fixed. Okay, if we don't have these joints, one of the link is fixed, so we have actually 2 links which have 3 degrees of freedom. That means 6 degrees of freedom. But now we have 2 joints here. Okay, so 2 joints here, that means you need to deduct, you need to write here 3 minus the no 6. So we are writing it 2 into 2. Is it correct? Let me write
Yes,
it
sir.
this way. 3 into, how many links are there?
4.
So 3 into 4 minus 1, that means we have 9, and 9 minus 6 would be there. I'm writing it this way. Okay. Both of these example 1 and 2, what kind of joints are there? Binary joints, right?
Yes.
Hello.
Yes.
Yes, sir.
Binary joints.
Yes, sir. Yes.
So here, how many binary joints are there from in the first example? How many binary joints?
2.
Two one.
Two binary joints. How many binary joints here?
3.
3.
Three.
Three binary joints. And according to this example 1 binary pair, the same example you see, this you just look at this. This number is 1 multiplied with 1. Okay. For the ternary joint, this number is 2. Quaternary joint, this number is 3. So ith order joint, this number is I minus 1. So if I just multiply it with a 2 minus 1, that means 1. For binary joint, I'm using this 1. Let's see, it will be clearer to you. Now, for this case, third example, how many links are there?
4.
4.
And now 2 multiplied with, what should I write here, the number?
2.
This is 3. 3 into 3 is 9. 9 minus कितना होगा? तो 3 होगा.
6.
Here,
3 6 9 minus 6.
2 into 3.
this is fine, right?
Yes.
But let us now take care of this. There is one binary joint and one ternary joint, right?
Yes.
Yes, sir.
One binary joint, one ternary joint. And I can write the same formula this way. 4 minus 1 minus 2 into 1 into 1 minus 2 into 2 into 1. First, you tell me whether you agree with these numbers or not. Then we will go for why I have written this. You agree with this, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
I will take 5 minutes more because we have started at 9:35. Okay, I will take 5 minutes more to finish this class. Okay, is it fine with you?
Yes, sir.
Yes.
Yes, sir.
All right, all right. Now let us go for this one. Okay, seems complicated than the others. So this is 8. Okay, now 3 into how many links are there?
9.
9.
9.
There are 9 links, right? If I not make any mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have defined that the degree of freedom is 8. So 9 links minus 1 minus what is the number I should write here?
8.
2
2
into
into 1 into 1.
Into 8.
2 2 into 2 2 into 2 into
2
2.
into 8.
2 into
20.
2.
2 into 8.
8, sir.
8 होगा.
8. Okay. So let's keep this one like this. Now, how many binary joints are there?
2
2.
1.
2.
2.
So I am writing it like this. How many ternary joints are there?
One.
One.
One binary.
One square.
So for binary joint, we have written this number of binary joints. For ternary joints, we have written how many ternary joints are there?
One.
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 How many quaternary joints are there?
One, sir. One.
Zero.
Not it. It is not a quaternary joint.
Zero.
Fifth order joint.
Sir, zero, sir. Zero, sir.
It's a fifth order joint, right?
Yes.
Yes, sir.
Yes,
Zero.
sir.
Zero.
So fifth order joint, we can, how many fifth order joints are there?
Only one, sir.
One.
One fifth order joint. And for fifth order joint, we will write it 4, right?
4.
I minus 1. Here, I minus 1. Okay, because this number is 1, so you can also multiply with it 1. Now, is this number fine? Is this calculation fine?
Yes,
Yes,
sir.
sir.
8 हो
Yes,
रहा है
sir.
कि नहीं?
Yes, sir.
Yes.
हो रहा है ना? So
Yes, sir.
the
Yes, sir.
same thing we have done for all this. For the first calculation, you see this is number of binary joint, right? And no, yeah, this is for number of binary joint. Binary joint. And for binary joint, we use this number 1 because for binary 2 minus 1 is 1. Okay, in this case, what is that number? Number of binary joint is 3. Okay, and for binary joint, we use this number 1. In this case, what is the number of binary joints?
One.
One.
This is
One,
the
sir.
number of binary joint. This is the, all right. And how many ternary joints are there?
One, sir. Only.
One.
Okay, so I'm just changing this numbers order. 2 and 1 लिखा हुआ है ना, उसको 1 and 2 लिख रहे हैं, ठीक है? ठीक है ना, कोई issue नहीं है ना? Just
Yes, sir. No, sir.
this is the number of ternary joint, and these 2 stands for this I minus 1. यहाँ पे जो multiply किए थे ना, I minus 1. So if this is a ternary joint, 3 minus 1 gives you 2. Now come to this calculation here. So I'm just changing in this multiplications, if we have taken number of joints second, so let's do that. Here I am writing 1 into 2, and here I am writing
2 into 1 into 4.
1 into 4. Is it fine?
Yes, sir. Yes, sir.
So now you tell me what is this?
So binary.
Number of binary joints.
Number of binary
Binary
joints.
joints.
Okay, what is this?
Number of
Number of
ternary.
Number of tertiary joints.
Number of ternary joints. What is this?
Number of
Fifth order.
ternary.
Number of
Fifth order.
fifth order joints. ठीक है? So in general, for this, when we generalize this formula, we can generalize this formula and write it like this. The degree of freedom of a kinematic chain F is equals to 3 into n minus 1 minus 2 into J1 plus 2 J2 plus 3 J3 plus, at least for J4 तक लिखते हैं, and then we will J4 and this way. Okay. Now in this formula, let us apply reverse back for the last example. If we apply last example for the last example, where n stands for number of links, capital N, number of links. J I minus 1, this stands for number of ith order link. ठीक है? So in the last example, 3 into number of links was 9 minus 1 minus 2 into how many binary joints? This J1 means number of binary joint, right? From this definition.
Yes, sir.
Yes.
Number of binary joint. How many binary joints are there?
2.
2. Plus 2 into J2 means, according to this definition, J2 means
Ternary.
number of ternary joint. How many ternary joints are there?
1.
Only one.
Plus 3 into J3 means
Quaternary joints.
how many quaternary joints are here?
Zero.
Zero.
Plus 4. 4 into how many? Fifth. J4 means
5th order.
Fifth order joints.
how many fifth order joints are there?
1.
1.
Only one.
One.
Any higher order joint is there or not? नहीं है ना? ठीक है? Now can you tell me what is this number?
8.
Now are you convinced that this is the formula for degree of freedom of any kinematic chain?
Yes, sir.
Yes, sir.
Yes, sir.
What you can do, you can draw any complicated mechanism, draw kar lo, and then you just convince yourself that this only, oh, okay, you just use revolute pairs, because there are other things we are going to discuss in our next class. Okay. So if suppose there is only binary pair in a mechanism, only binary pairs are there. Okay, so that means this J2, J3, J4, these are 0. In that case, what is the degree of freedom? Right? This is the degree of freedom where J is the J1 actually, but I am writing J. J is the number of binary pair. Convinced? Is it fine?
Yes, sir.
Yes.
So
Yes.
this
Yes, sir.
is a equation you have, I don't know whether you have studied or not. This is called Kurzbach equation. Okay. Let's stop here today. If you have any doubt, you can ask me.
सर ये नोट्स हमें टीम्स के नोट सेक्शन में मिल जाएगा ना?
Yes, I will upload in the team section. The PDF of this note I will upload.
थैंक यू सर.
Have you enjoyed this class?
Yes,
Is it
sir.
fine?
Yes,
Yes, sir.
Yes, sir. Yes, sir.
So what I expect from you, you guys must respond during the class. If you respond, it will become more interesting. If you don't respond, and I don't know how to go forward. Okay, so what you need to do, you the same thing you must go and practice. You must understand how this formula came into existence. Okay. Yeah, in our next class we'll discuss some more restrictions in this formula, because this formula is not absolute. Depending on the mechanisms and other things, you will see that in the next class. You will see that some of the restrictions need to be included, and when you include those restrictions, this formula will have some other form. Okay. So our aim is not to stick to this formula. Our aim is, if you have a real life problem, then that real life problem, you have to solve that problem, right? So if you know the basics, very basics, then you can solve that problem easily. Okay. So I want to thank you for your attention. Let's see you tomorrow.
Thank you, sir.
थैंक यू सर.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.